Today I want you to understand a lot of property of logarithm. So I think in this video everything gonna be clear for you. Okay. In fact, what it is when I say logarithm of x. In fact, logarithm of x doesn't mean anything. I should understand. I should read it like log base b of x. So the base is really important. If I say log of x, I don't know the base, that doesn't mean anything. So I should understand what is the base. When I say log base b of x, okay, it's really important to know what is the base, because the base will help you figure out the result. So what I mean when I say log base b of x, what I'm looking for, in fact. So I'm trying to find out what is the exponent. So the result, that's mean I'm trying to find out what is the exponent. So what I'm trying to find out is a number that I can call y. Okay, this number, I'm trying to find out what is the exponent y of b, such as b to the power of y equal x. Okay, it's really important to understand when I try to compute log base b of x, I'm trying to find out what is the exponent, the power of b, such as when I have b to the power of this number y, I end up with x. Okay, let me repeat it again. When I'm trying to compute log base b of x, what I'm looking for an exponent of b. That's the unknown that I'm trying to find. What is the exponent of b, such as when I have b to this exponent, I end up to the result of x. Okay, that's why you should understand when you compute log base b of x. Okay, let's take an example. Let's say I'm trying to compute log base 5 of 125. So it's the same to, I can write it differently. So what I'm looking for, let's put this equal y. Okay, y is the unknown that I don't know. Okay, that's the result. Okay, so I'm trying to figure out these numbers, such as 5 to the power of y, that I don't know, equal 125. Okay, so what is the exponent of 5 that will give me 125? I remember 25 by it should be, you can try 5 by 5 to give you 25. 5 times 25 give you 125. So this will be 7 to the power of y equal 5 to the power of y equal 5 to the power of 3, because 5 times 25 give you 125. So y equal 3 here. Okay, so that's why we should understand when I'm trying to compute logarithm x with a base b. So I'm trying to figure out what is the exponent of b, so that when I have b to the power of this number that I don't know, it's equal to x that I know. Okay, so we can take this example also. So log base 2, I'm trying to compute log 16 with the base is 2. So the number is unknown, the result, which is y, I don't know this result. So I say 2 to the power of y, I don't know the y, equal 16. Okay, so I can write this differently. 2 to the power of y equal 2 to the power of 4, because 2 by 2 by 4, 2 by 4 done 8, 2 times 8 done 16. So y here is equal to 4. Okay, so I repeat again, so this is really important to understand. When I'm trying to compute log base b of x, what I'm looking for an exponent of b. The question is, what is the power of b which give me this value of x? What is the power of b? B is the base which that will give me this value of x. That is why I'm looking for when I'm trying to compute log base b of x. Okay, now there is some notation that you should understand. Even though the base is really important, but most of the time by conventions, when we have base 10, we don't write anything, we just write log of x. So on your calculator, when you see log of x understood, it's always 10. That's by conventions. By conventions, the notations log of x, they usually take the base 10. Okay, but other base, if you have the base 5, base 3, for example, for this problem the base was 5, the base was 2, so we put the 5 here, we put the 2. But when we have 10, most of the time we don't put anything, we just assume. If you don't see anything, that means the base is 10. This is by convention, we accept it. We never write base 10, we just write log. That means log of x, which the base is 10. Okay, log base 10 of x. Okay, log base 10 of x. That's the same also when we have the base is e. Whenever e is a number, the number of Euler 2.71. So when the base is e, it is usually written like this. Ln, we call this logarithm natural, ln x. So when you see ln x, that means you're trying to compute the log of a value, the log base e of x. Okay, that means the base is e. So usually we don't write the base e, we just write ln x. That's by conventions. Okay, I hope you understand. So on your calculator, mainly you see these functions. That means the base is 10. Okay, that's by conventions. Okay, but I'm gonna repeat it again because this is really important to understand. This is really important to understand. I'm gonna repeat it again. When you have log base, whatever the base b of x. Okay, what are you looking for? The question, what is it? You are trying to find an exponent of b, the power of b, which give me x. So what I'm trying to looking for, this number. Okay, what I'm trying to looking for, the question, I'm trying to look for a power of y, that we should know. That means I'm asking my question, what is the exponent of b which will give me the value x? Always remember, this is really important. When you're looking for the logarithm of a value, you're trying to find out an exponent, a power of the base that will give you the value. Okay, okay, now understand also that whatever the base, log of x exists if only x is superior to 0. That means you can't compute the value of a negative number, you can compute the value of 0. Okay, that's not possible. So if I ask you log base 2 of minus 8, this is impossible. Understand why log base 2 of minus 8 is impossible. Okay, let's do the same thing. You remember what I'm trying to looking for is a number unknown. Okay, is the y. The y, what is this? That means the base is 2. I'm trying to find what is the exponent. That means I can read this is can be written in another way. That means I can say what is the power of 2 that will give me minus 8. Okay, so we say there is no exponent that can give me a negative value. So if I have my base is 2, you can try with 1. If I have 1, it's gonna be 2. If I have 2, it's gonna be 4. Okay, if I have 3, it's gonna be 8. Try let's try for a negative value. If I have 2 to the power of minus 1, it's gonna give me like 0.5. If I have 2 to the power of minus 2, I think it's gonna give me 0.25. You can try by yourself. Take any value for the exponent, any negative value, any positive value. Never you will end up with a negative value. The result will always be positive, so this is impossible. Okay, so for any value we say the x, the logarithm of base b, okay, exists. This means exists if only x is superior to 2. So that means you can compute logarithm of base b of any value that is negative of 0. It should be normally more than 0, superior to 0. That's the domain of the definition of any logarithm value. Okay, now other property, let's say we have log x times y. Okay, a multiplications, two value, log base of base b x times y. So these multiplications will be transformed to an additions. If I have log base b x times y, this is gonna give me log base b of x plus log base b of y. That's a property for a logarithm. Any multiplications of a value will be converted to additions. Okay, that's a property. We may in another video explain the reason of this transformations, but right now just remember this property. What about this property? They say log base b of x to the power of n equal n times log of x. In fact, this property can be explained with this one. So if I have x times x times x, that's when you have x to the power of n, in x by himself a number of times. So this will give me log x plus log x plus log x. You say that means if I have x times x times x, that means x to the power of n, I will end up with log x plus log x plus log x. That will give me n times log x. So that's why when I have log x to the power of n, will give me n times logarithm of x. Okay, that means this property can be explained by this property also. Okay, because we say when we have multiplications, this is transformed to additions, because when you have x to the power of n is a multiplication, it's x by himself another of time. That means we're going to have logarithm of f x plus logarithm of x another of time. This would give me n times logarithm of x. Okay, another property also, if I have logarithm of x over logarithm of y, for the division they say this will be transformed to an subtractions. If I have a division in a value, I can say logarithm of the numerator minus logarithm of the denominator. This can be explained also with this property. Why? Because let's say let me try to explain this one with the same property. Okay, let's say if I have log, I'm gonna try to explain. If I have log x over y. Okay, I'm going to try to explain you this with the same property. So I can say this can be written like logarithm of x time. The y can be written like an exponent. This can be y over minus 1. Because we have the y in the denominator, I can put it up by written like this is, can be written like y over minus 1. Okay, let me explain you better so you will understand it better. So understand, this is like 1 over y. I hope you agree, eh? If I have log x over y, this is like log x times 1 over y. This is the same thing, okay? So this is like now x time, this is can be written like, you remember this property of exponent, so this is can be written like x to the power of minus 1. Okay, remember the property when you have in high school, if you have a number, 1 over a number can be written like this number to the exponent of minus 1. Okay, now that means this division will be transformed to multiplications. So remember the property of the multiplications. So that means this property, I can make an additions, right? So I can make an addition here. So I can say this is a log of x, right, plus log of y minus 1. Okay, now remember also we have this property, any exponent, I can, if I have log x to the power of n, this is can be like n log of x. So I'm gonna write this, I have log y to the power of minus 1, so this gonna give me like log x. Okay, so the minus 1 gonna be here, so I'm gonna have minus log y. Okay, I hope you understand when I multiply by my, so this property is really understood now. So when you have a division, this is convert to the subtractions. Okay, when you have a division, this is convert to subtractions. And what about this property, log 1 equals 0? Why log 1 equals 0? Log 1 equals 0. Understand, whatever the base, if I have log whatever the base, if I have log base b of 1, okay, what I'm trying to remember, I'm trying to find the exponent. That means what is the exponent of b such as I have that equal to 1. Okay, whatever the base to have 1, the base should be 0. Remember, whatever when you have a power, the power should be 0. So it's here b is 0 because b, whatever the b to the power of 0 give me 1. So the log of 1 equals 0. Whatever the base, we can try for a base. Let's say if I have log of base 2 of 1. So what I'm gonna try to figure out, 2 to the power of y equal 1. Now what is the exponent? Such as when I have 2 to the power of this to the power of y, that give me 1. So the only way to have 1 here, y equals 0. You can try for whatever the other base. Let's say I should base log base 5 of 1. I'm trying to figure out what is the exponent, such that when I have 5 to the power of y, this gives me 1. So both I will have here y equals 0. 0. Here also y equals 0. So whatever, remember this is really whatever the base, log 1 gonna always be 0. Okay, so remember those property when we have a multiplications for logarithm. This will be transformed into additions. If we have log of x to the power of n, this can be written like n log of x. If we have a divisions, this will be transformed to a multiplications. When I have log of 1, whatever the base, that will give me 0. Okay, remember also you can have log a negative value. That means log, you always compute log of a positive value, because I try to explain you with 2. If I have 2 to the power, whatever the value I can give to y here, I will never have a negative value. So you can't compute a log of a negative value. Okay, so that's really important to understand. Also, notations, generally speaking, if you see log x with any base, understand the base is 10. If you see log x, understand the base is e. Okay, but for other base we usually write the base, but for 10 we don't write anything. For e we write ln x. Okay, so now the last rule, we call it the cancellations rule. What is it? If I have b log of base b log of base log b of the base b of x, that's equal to x. Okay, an example, if I have 2 and I try to compute log of x, the base is 2, that give me x. Okay, that's a cancellation rule. The same thing, e to the power of ln x, that give me x. Okay, so it's really important to understand it's like I'm doing something and I try to try to redo it. Okay, so when I have base b to the power of log base b of x, that give me x. An example, 2 log base 2 of x, that give me x. And I have the base is e. Okay, e ln, remember this is base e, ln is base e. It's the same to say log base e of x, so this will give me x. Okay, understand also, this is when you have exponent. Let's say if I have log base b to the power of x, that give me x. So this is really to understand, this is really easy to understand. So let's say I'm trying to figure out log base 2 to the power of 5. Understand what I'm trying to figure out here. What is the exponent? Remember, what is the exponent of 2 that will give me this value? That's mean the unknown, which is y. So I'm trying to figure out what is the power y that will give me 2 to the power of 5. So this is really easy. That give me y equal 5. That's why we say when you have log base b, whatever the base, b to the power of x, you will always have x. We call this the consolations law. Okay, so that's all for different property that we have from logarithm. I hope you understand them. Next time, for the next video, we're gonna try to resolve a lot of problem about logarithm. I hope you understand those, but for next video, we're gonna try to solve different problem on logarithm. I hope you enjoy this one. So see you for another video, and then we try to resolve a lot of problem for another video.